Here again we're going to do partial fraction decomposition. I have an s squared at the bottom, and so the s squared needs to be broken up into a over s plus b over s squared. Then the s plus 2 at the bottom, I'll have a c over s plus 2. And then for the factor s minus 1, I'll have d over s minus 1. If I multiply through by the common denominator, then I'll be left with s squared plus 2 is equal to a. Here I can cancel out one of the s's, but I'm still left with an s, and s plus 2, and an s minus 1. Then I have plus b. Here both of the s squareds, both of those s terms, factors drop out. So I have b times s plus 2 times s minus 1, and then plus c. Here the s plus 2 drops out. We get cs squared times s minus 1. And then for my d, the s minus 1 drops out, and I get s squared times s plus 2. I'm going to expand this. I'm going to start by multiplying out these binomials. This will give me an s squared. It'll give me a negative 1s plus 2s. When you combine those, you get plus s, and then minus 2. And here again I get s squared plus s minus 2. Here I can just distribute to get cs to the third minus cs squared. And here distribute to get ds to the third plus 2ds squared. And now I'm just distributing as to the third plus as squared minus 2as plus bs squared plus bs minus 2b, and then just copy down the rest of the terms. And then our next step is going to be to equate the coefficients, and so I want to combine my like terms. Start with my s to the third terms. Factoring out s to the third, I get a plus c plus d s to the third. And then my s squared terms. I get a plus b minus c plus 2d For my s terms, I have negative 2a plus b and then for my constant term, I just have negative 2b. Okay, so let me start by equating my constant terms. I have, on the right side, I've got negative 2b. On the left side, I have that's equal to 2. So for my constant term, 2 equals negative 2b. Divide by negative 2, and we get b is equal to negative 1. And then for my s terms, I don't have an s term on the left side, so that's a 0. On the right side, my s term has a coefficient of negative 2a plus b. b is negative 1, so let me bring that 2a over, and I get 2a is equal to b, which is negative 1. Divide by 2, and you get a is equal to negative 1/2. Okay, for my s squared terms, here I have a 1s squared on the left side, and on the right side I have a plus b minus c plus 2d. Well, I know a and b, I don't know c and d. So let me substitute in. I'm going to get 1 equals a is negative 1/2, b is negative 1, minus c plus 2d. This is going to give me a negative 1/2. And if I add 1/2, it'll give me 2/2, or 5/2 on this side. 5/2 is equal to negative c plus 2d. And let me solve this for c so that I can use it in the next equation. This will become c, bringing the c over to the left side. And if I bring the 5/2 over to the right side, I get c is equal to 2d minus 5/2. So on my last equation, when I equate the coefficients of s to the third, because there's no s to the third on the left side, I get 0. And on the right side, that's equal to a plus c plus d. A is negative 1/2. C is 2d minus 5/2. And then plus d. So negative 1/2 and negative 5/2 combine to give you negative 6/2, which is negative 3. If you bring the negative 3 over to the left side, it becomes 3. And then 2d plus d gives you 3d. Divide by 3, and we get d is equal to 1. And if d is equal to 1, then we get 2 minus 5/2, which is 2.5, gives you a negative 1/2 is c. Okay, so let me fill these in for my fractions, and then we'll apply the inverse Laplace transform. I'm going to erase these coefficients. So we know it's a, b, c, and d. And then we'll fill them in. A is negative 1/2. B is negative 1. C is negative 1/2. And D is 1. So if I apply the inverse Laplace transform to everything, and I think I have room down here, the inverse Laplace of f of s is f of t. And then for each one of these, you're going to bring the coefficient out. So I'm going to get negative 1/2 times the inverse Laplace of 1 over s. And the inverse Laplace of 1 over s is just 1. So I get negative 1/2 times 1. There we go. And then minus 1 for my second term. And the inverse Laplace of 1 over s squared is t. My third coefficient is minus 1/2. The inverse Laplace of 1 over s plus 2 is e to the negative 2t. And then the last coefficient is just a 1. And the inverse Laplace of 1 over s minus 1 is also this exponential function where a is 1. You get e to the t plus e to the t. Okay, so let's solve this